Hi, my name is Chris Ambrose. I'm a lab instructor, and this is the sound of my voice. I'm going to show you how to find the boiling point of your unknown. In order to more accurately get the boiling point, you're going to need to calibrate your thermometer. Calibration is a process where you compare the reading of an instrument to an accepted reading. For example, if you wanted to calibrate your watch, you would compare its time to the time of an accepted timekeeping device. So this is a screenshot from the atomic clock, which keeps a very accurate time. And what you would do is set your watch to the time that it shows. That's what calibration is. So you're going to be using the thermometer that's on the left-hand drawer in front of you. This thermometer is an alcohol one. And if we zoom in on the scale, we see that each line represents a degree. What we can do is estimate to the nearest tenth of a degree. So for example, if the temperature was right there, this number would be 15, 16, 17, and somewhere between 16 and 17. All right, so about 17.8. It's important to realize that if the temperature is right on the line, you have to indicate that to the tenth of a degree. So this reading right here would be 14.0. All right, so calibration involves putting your thermometer, using the thermometer clamp, into a beaker containing deionized water and a small pinch of boiling chips, just to make it boil more evenly. And assuming that the water is boiling at 100.0 degrees, we want to know what your thermometer is reading the temperature to be. So let's say, for example, that the temperature of this water, as read by the thermometer, is 102.0 degrees. So clearly there's a discrepancy. The thermometer says 102, and the water, we're assuming, is 100.0, which is a safe assumption since the deionized water is pretty pure. So what we're going to do to calibrate the thermometer is to come up with an error value. So we have the 102.0, the accepted is 100. By taking the 100 degrees minus 102.0 degrees, what we get is a thermometer error value of minus 2.0. The reason the sign is important is because sometimes thermometers can read too low or they can read too high. Because our thermometer is reading too high, that means we need to subtract 2 degrees. That's what the negative sign is telling you. So let's say you get the boiling point of your unknown using this error value. Your thermometer says 65.0. Well, we know from using the thermometer that that temperature is actually 2 degrees too high. So we need to subtract 2 degrees, 2.0 degrees. So in reality, a more accurate value of our boiling point is 63.0. Now, to get the boiling point of your unknown, we're going to find it by heating up the vapor, and we're going to be looking for a specific thing to happen. So overall, the objective is to heat your unknown past its boiling point. So let's say that this is the actual boiling point. What you're going to do is heat it up in a water bath past its boiling point, cut the heat, and let it cool. It's going to cool on its own. So what this means is if you heat it up too far past its boiling point, it's either going to take a really long time to get back to the actual boiling point, and or your unknown could evaporate. So it's important to only heat it a little bit past its boiling point. As it cools, you're going to be looking for something to happen, and we'll talk about what that is in a second. Here's what you're going to be looking at. You're going to have a little test tube with your unknown in it, and you're going to put a capillary tube into this test tube. Capillary tube is open at the bottom. You're going to heat it up past its boiling point, and what you'll see once you get past the boiling point is that bubbles will come out very rapidly from the capillary tube. As it cools, the bubbling is going to slow down. Eventually, when you hit the boiling point, One more bubble will leave that capillary tube, and at that point, that temperature is the boiling point. Because what's happening is we've boiled the liquid, and as it cools, we're actually watching the gas condense back into a liquid. Well, the temperature where that happens is the same as the boiling point. So the temperature where you see that last bubble leave is the boiling point of your unknown. Here in the materials, these will be set up in the lab in stations. You can find all of these. The one thing is that this thermometer right here is going to be the one that you calibrated at the beginning. Otherwise, we have a capillary tube and a small test tube, and then this is a rubber band. To set it up, you're going to take your calibrated thermometer, put the test tube, and notice where it's at. We have the bottom of the test tube there. We have the middle of the thermometer bulb. That's where you want it to be. Rubber band it on. That can be a little tricky, so see your lab instructor if you need any assistance. Fill it up about 3/4 full of unknown. It doesn't have to be exact. Boiling point does not depend on amount. Capillary tube goes in, open end at bottom. Very important. Middle of bulb, we talked about that. Okay, this whole shebang is going to go into a water bath. Now what's important is you want the water level to be slightly above the liquid level of your unknown. Not the test tube, you don't want that totally in the water. You want your liquid unknown to be under the water. Very important. You have a thermometer clamp up here. There should be a screw over here that you can use to screw it on and hold it in place. You don't want this whole thing resting on the bottom of a beaker. All right, heat it up. And ironically, if you heat it up slowly using a smaller flame, it will save you time. Because remember, what we're doing here is going past the boiling point. If you heat it up really fast, it's going to go way past the boiling point, and you're going to be sitting there waiting longer for it to cool down. Okay, again, unknown is under the water. For this part, you can use tap water. That's fine. All right, so initially what you're going to see is a couple of bubbles will come out of the capillary tube. This just represents trapped air. We don't care about that. Okay, so you keep heating. Eventually what you'll see is the bubbles will be coming out rapidly, almost as if someone's blowing through a straw and bubbles are coming out. If you want to lift this capillary tube up a little bit, that will help you see the bubbles a little bit better. Okay, so watch for that happening. Once you see that happening, turn off the heat at the sink where the gas jet comes out of the wall, and it's going to start to cool. So as it cools, the bubbling is going to slow down. And remember, what you're looking for is that last bubble to come out. When you see that happen, you get your temperature, and that's your boiling point. What you might see after that is a little bit of liquid may travel up the capillary tube. If you've seen that, it's probably a little bit late, but just get the temperature just in case. All right, you're going to do another trial. You're going to need to replace some things. You're going to need to replace the unknown, or just put more in the test tube, 3/4 full. You're going to need a new capillary tube. The capillary tube is made out of glass, so it has to go into that blue broken glass box that you can find in the corner of the lab, and see your lab instructor if you don't know where it is. Bear in mind that when you're working, all of the unknowns you're working with are flammable, so just keep that in mind when you're working with an open flame. The vials that the unknowns are in should have the cap on them unless you're taking something out. All right, this ends how to find your boiling point.